Good morning, everybody. Welcome to today's webinar from OMRON, titled 2 Minutes to Vision. The purpose of today is we're going to explain how advances in technology have made machine vision a lot more accessible to manufacturers across the UK ecosystem. Joining me is my colleague, Neil Harvey. Neil, do you want to just give us a quick intro?
Yes, morning everybody, and thanks for joining us today. Hope the weather's nice and warm where you are, and we're sat in a nice aircon office somewhere, like some of us. But yes, I've been with OMRON for over 10 years. My background is totally automation. That's what I've been throughout my career. So I've kind of seen the concept kind of evolve of lower cost machine vision systems when they first started to appear, and forge ahead with new markets in comparison to maybe the older sort of PC-based stuff. So looking forward to sharing the sort of latest technologies with you this morning, and hopefully answering any questions you might have towards the end.
Thanks, Neil. And for those of you that don't know me, I'm Stuart. I'm the marketing manager for OMRON in the UK. So to kick us off, I've got a few slides to share. Don't worry, we've not got an hour of death by PowerPoint. We should really only have around 10 minutes of slide content to share. If you give me a quick second, quick little technical malfunction there. Okay. So, quick agenda for today. We're going to spend a little bit of time first up going through some of the common use cases for machine vision, talking about how they arise, what the impact on production can be, but also how AI is starting to creep into this world and give us an idea of how some of these harder to solve problems can be looked at. We're then going to do a Q&A with Neil, our resident vision expert. So really looking forward to that one. And then even more looking forward to the live demonstration of just how easy this technology can be to set up and deploy in your factory. And then at the end, we invite the audience to ask any questions they might have. Of course, we have the live chat in the webinar as well. So if you do have any questions, either wait till the end or feel free to drop them in the chat, and we'll answer them for you. If we run out of time, we will come back to you individually to answer any questions that you might have. So to dive into some of these use cases, then, we've kind of identified kind of 4 broad use cases that covered the majority of what we would look at. We're deliberately not touching code reading so much here because code reading technology often follows the same principles now with vision, particularly the value messages in terms of it being easier to use are very similar, and we will touch on those during our expert Q&A. But from a use case perspective, the obvious one clearly is defective product reaching the market, which I'm sure many of you that have been manufacturing products in the UK have experienced. It causes a lot of headaches, the biggest one really being brand damage, but it also has quite a significant knock-on effect in terms of remediation. So what we try to look at here is what happens. So clearly a product that doesn't meet the required specification passes through the line, comes out the other end, and in the worst case reaches end customers, retailers, or in some industries even auditors, which can often have significant consequences. And really the main reason why this happens is when we look at sampling or rule-based inspection, it's very difficult to achieve 100% coverage on that by definition, particularly on high-speed lines. You add into that subtle defects, for example, a very, very light scratch on a high value finish on the inside of a car. All of a sudden it becomes really, really challenging to achieve that level of inspection. So, some of those harder to detect ones are the ones that we see the most reaching the market. And whilst it doesn't always get spotted, some of the eagle-eyed consumers in particular do spot it, and it causes problems later on for the manufacturer. What we also find is that a lot of these defects tend to cluster during startup and towards the end of a shift or a production run. The impact, obviously, in some certain industries, particularly those that are heavily regulated, product recalls cost an awful lot of money, not just in terms of the logistics cost of taking the product back and replacing it, but the cost to the brand as well is huge. And you know, as an engineering and quality team operating in a factory, the burden of rectifying said issues often falls on those people who are already maxed out in a lot of cases. Regulatory action as well is another obvious consequence here, which can you know, can really run into significant fines, often running into 7 figures. And then, you know, if you're selling to one of the major retailers in the UK, it's not uncommon for quality issues to lead to delisting or at least deprioritization of products being put on the shelves, obviously affecting business growth in the short and medium term. So AI, how can that help? I mean, we're starting to look at a lot more AI technologies, and Neil will explain this in a little bit more detail later on about subtle defects, but being able to actually use AI to identify some of those more subtle defects can start to actually reduce the number of defective products reaching to the market on top of traditional inspection methods. So, you know, a nice little line to sum that up is it takes a relatively short amount of time now to deploy some quite high capability technologies to avoid these defects getting to market, but the cost of not doing it is often quite significantly more. So the second use case is around the impact downstream. So that is parts entering a process in the wrong state. So they could be the wrong way around. They could be the wrong part completely. So if you think about if you're packaging bottles of flavored water, for example, and you've got strawberry water that comes with a nice red cap, and then all of a sudden an orange cap is presented to the machine, you've got a little bit of a problem there. So these things sound ridiculous, but they do happen. So the process in some cases can jam up if the part's presented the wrong way. So if it's an oddly shaped part that needs to be in a specific orientation and it turns up, it can jam the process. You could rely on someone noticing it, picking it up and turning it around, but then you're creating bottlenecks in your processes, or in the worst case, you're producing a product or applying value to a product that when it gets to the end of the line can't be used. So these are often introduced at the feeding stage. So it's important to have those inspection processes being implemented as early in that process as possible to make sure that we're rejecting as early as possible and not adding value to those work pieces for them to ultimately get rejected. And again, the production impact, as we've already touched on, an assembly malfunction is something we see quite a lot. You get things that fail to go together in the right orientation. Some of those hard to see misalignments with quite small tolerances are often root causes of this, particularly in high precision industries like aerospace or high-end automotive. And these are often things that there's no chance that you would be able to see it with the human eye. So by the time they've actually got through and reached the target process, the problem is often unavoidable. Product rejection after value is added is very much just a waste of resources. If we go back to our orange cap on our strawberry water example, we're often then applying a strawberry water label, which doesn't need to be applied. If we can get the right cap to begin with, we're eliminating that inefficiency from the production process. And the quality escape issue is, again, with those kind of low contrast surface damages like light scratches, for example, and things that are right on the cusp of whether it's good or bad in terms of threshold setting, very common in rule-based vision. These are often the parts that are most likely to reach the customer. So again, Similar sort of thing with AI, actually being able to use additionally enhanced tools to be able to detect some of those surface defects that are really, really minor and often imperceptible to the human eye, really help to improve that level of quality that is going out. So, in a lot of cases, we do see that the downstream machine is performing exactly as it's supposed to, but is often blamed for quality issues coming out the other end. But the problem was introduced long time before that. The third one is unplanned stops and loss of throughput, which essentially is around and is very closely linked to the last use case, but is about machines jamming up, often because the wrong parts have gone in. So we're going to skip through this slide a little bit more because there's a lot of repetition from the previous one. But what's really important here is the cost of manual interventions. So it's not just about the cost of having to scrap stuff at the end of the line if it's not right. It's also the cost of getting a highly skilled person to come in and actually identify the cause of the jam, not just remove it, but identify the cause of it, put a plan in place, often having to go away and research the right technology to rectify that problem. There's a huge time cost and opportunity cost there, because that's time that that engineer is not spending on other tasks. And eventually, if we've got a jammed up machine, we can't use it, so machine availability drops, OEE ultimately drops as well. And sometimes we often see things, yeah, but it's only stopped the line for a few seconds, so it's not really a problem. But when you start to look at an 8-hour shift and you're losing 3 or 4 seconds an hour, all of a sudden that starts to mount up over a longer period of time. And if you look at that on a monthly or even yearly basis, the losses that you're getting in terms of throughput are often quite surprising and alarming. So we've kind of already touched on that engineering capacity for more reactive stuff. But again, as we discussed on the last slide, that root cause can often be attributed to more downstream processes, when actually the real root cause lies further upstream on the manufacturing line. So there we say the most expensive ones are the ones that happen multiple times a shift, but never really get fully investigated. So I think it's an important point to take away from today. And then the final use case we've looked at is again a very, very common one, and that's around false rejects. So the previous three have really been focused on making sure we don't let defective product through. But what about in the case where actually we've got a little bit of an oversensitive inspection process that is rejecting product that should actually be allowed through? So a unit that is absolutely within the required specification, it looks great, it meets everything that we need it to do, but there might be one little aspect of it that is close to the threshold and can then lead to it being classified as defective. So there is a bit of a tension here, and it's not an easy one to achieve with traditional rule-based systems, and actually making sure that we have tight enough tolerances to make sure that we have as higher quality rate as possible, but then dropping it to where it needs to be to make sure that we're not having these false rejects often is a very, very challenging task. And I'm sure Neil will agree, it's probably something that you end up spending quite a lot of time and get quite a lot of headaches trying to overcome. So what does that lead to? You end up with a lot of unnecessary rework, scrap and material waste. We often actually see when we take it off the line, someone will take a look at the product and say, there's nothing wrong with this, it's perfectly fine, and it gets reintroduced to the line to be reprocessed, but it's an unnecessary action. We get an obvious reduction in first pass yield, which is something that we all want to maximize as much as possible to make sure we're producing the volume that we need to meet our customers' demands. And the cost is often absorbed. So it's kind of just accepted this false reject thing as just a part of manufacturing, but it doesn't need to be. If we can actually identify that root cause by using some more advanced but easy to deploy inspection techniques, we can easily attribute those issues to the right process, fix them, and improve our overall productivity. So setting the inspection threshold, it's not a quality decision only. There are costs on both sides, so that's something that we've got to think about. So we've kind of touched on on some of the use cases there of where we often see inspection systems being used, and that's rule-based, but we're also seeing AI coming into these as well. I want to start having a discussion with Neil now on how technology has evolved and what that means to people that are using inspection technology. So Neil, let's start nice and easy, nice broad question.
Good.
As we are today, what are the traditional attitudes to implementing vision and also code reading in the manufacturing industry?
Yeah, that's an excellent place to start, really. I think I touched upon at the start that some years back, off the shelf, if you like, vision systems started to appear. They were quite simple devices, and maybe a simple VGA camera, little control box, a VGA output, plug it into monitor, and maybe a pendant or something. They're very simple kind of image-based sensors, and since then they've evolved and they've kept evolving. And I think a lot of, they've got to a point now where, there's some quite complex systems on the market. Again, they might be controller based, able to handle multiple high resolution cameras and so on. So you've got a much larger area and complexity in terms of the technologies that are available, the camera technologies, lighting technology, and so on. So that all kind of starts to lead that, particularly maybe for those that are not familiar with vision or have very little experience, that, you look at potentially requirements in your own processes, but you see traditional vision systems becoming, become quite highly complex systems, rule-based functions with strict parameters. And maybe, the software that goes with it, is an endless selection of functions. You're trying to understand your application, which of those functions might be appropriate and which aren't, and it becomes a little bit of a toolbox, if you like, where you're trying to sort of root through it and work out which might be the best way forward. So there's all sorts of hurdles and complex areas that a lot of people don't really understand and see that as a barrier to actually moving forward and maybe implementing vision. And attached to that then becomes the cost area. What sort of budget restraints we have, what's the cost of these systems, and some of them can be quite high, again, depending on what sort of technology you need. And there's a huge capability now, as we know. If we look at our smartphones, they started off with very basic cameras. Now they all come with 12 megapixels and so on. So and similar with the camera technologies in vision, and not just standard cameras, but things like infrared cameras and so forth. So they're really reaching out to a vast array of applications. And of course, when we look at costs, we look at the complex issues that, how are we going to install it? How do we integrate that? Do we have the capability in-house to do it, or do we need a third party? And what sort of support do we need for that? And then there's the skill levels and training requirements. And, once we get it in, who's responsible? Who do we train? And if that person leaves the company, and, we've got to replace and retrain somebody else. And ultimately, we want to kind of adopt the ownership of that system. We want to understand it. We want to, to work with it and understand how we set it up, and particularly fault finding is a big area. If it goes wrong, how do we deal with that? Do we have to call somebody in all the time and to support that? And all the ongoing support issues that go with it. What happens if we've got new products, or we want to add things and things like that? Do we understand the system now? So I think there's a broad selection there of, increasingly the way vision can be perceived, particularly with those that maybe don't have a lot of experience with it. But increasingly, we all get in applications that need it. And we're there to try to sort of understand those applications, look at, the fact that a lot of them are quite simple. So maybe we're making the hardware and technology overcomplicated for a lot of what the market needs. So,
So is it fair to say then, Neil, that you touched on skill levels there, and we're well aware of the skills issues that we're facing in manufacturing at the moment. It's been well documented by many industry stakeholders, and actually, when we look at the skills required and those that currently exist, there's quite a big gap, which then I guess introduce extra costs for third-party integrators to come in to have to fill that gap. Does that kind of make it, does it almost overwhelm manufacturers even more in that respect?
Yes, it's the overwhelming. It's the cost implications. Where do you start, and who's going to supply those services? It's one thing, identifying what sort of solution you need in terms of hardware, but then who's going to support that? Where do you go? So it seems quite a lot of questions to answer, a lot of things to find out, and it's not always immediately obvious where you get those answers. What we try to do at OMRON is we try and offer those answers. We and understand what our customers need, and we try to develop a range of technologies. Some very simple, maybe some not so, but technologies that are there to deliver the kind of solutions that are being looked for. But increasingly identifying the area of more simple requirements. Really, we want to move away from that concept of high skills, high costs, and all that, and look at, and actually there are systems on the market now that don't require those sort of skills. Really, if you've never used a vision system before, if you can take a picture, with your smartphone, then that's really all you need to do. And we'll mention this dreaded term AI in a minute, but and things, but it's a familiar term. So to answer your question there, Stuart, I think that there are barriers, and they do hold progress back, for a lot of manufacturers, where they really could benefit from some level of vision solution, but really are put off in sort of going down that sort of road and investigating further.
Yeah, I think it's encouraging to hear that the technology appears to be being developed that enables increased accessibility, let's say, to a wider group of manufacturers due to the lower skill levels required. I'm conscious of the audience we have here today, Neil.
Yeah.
How do these attitudes tend to differ between, let's say, machine builders or system integrators in that are supplying into manufacturers and manufacturers themselves, or end users as we often call them? How do those attitudes differ?
There are some differences, certainly. You listen, through experiences. You listen to when you're talking to machine builders and stuff. They see a need, but it's implementing it. It's the cost effectiveness of doing that. It adds value to the machine, but does it add value to the process and things like that? They've got to get that balance right. If there's too much cost involved and no one sees the benefits, it's very difficult then to absorb that cost into the machine. So it really is, what technology now available that we can start to approach what is a feasible application requirement for vision, but in such a way that it's cost effective and everybody wants it. It doesn't become it'd be a nice to have kind of solution, but a standard machine will go out without it, and it's like one or a few might say, actually, we'll add that on. So the machine builder wants to make it a standard solution. They want it to be for everybody. So that machine goes out with that solution because it's cost effective and it delivers a real impact on the processes and what that machine's doing. From an end user perspective, it's all about managing their quality issues and things like that, and seeing the benefits there, and addressing skills issues and stuff, and how do they get to that level? So when they see a simple solution that offers great benefits, then we start to break those barriers down a little bit, and then users start to see that we're going to get some benefits out of that. We want that solution, and we can see the impact it'll have on those quality issues. So the similarities, everyone feels the same. Machine builders might have a little bit more experience with visions. They can see the benefits, but it's how do we get that solution? How do we get it right in terms of the costs and the impacts and so forth? But end users, they might not have that experience. They need to be shown, a way forward and introduced to, reasonable levels. And maybe it's a starting point as well, that we start off simple and potentially you start to learn what the capabilities are and how that might benefit further within your organisation and your processes you have.
Okay, yeah, great. We touched earlier on, Neil, on making the technology more accessible. So let's go into that, because I think that's the real the real meat of the webinar, isn't it? So how is technology starting to develop then? That is opening the door for these technologies to a wider group of people.
Key word here: simplicity. Technology. If I go back, what happened some years back when the first sort of low-cost vision sensors started to come to market. They evolved quite quickly, but under, I guess, the older technologies, if you like. So, software started to become more complicated, more, functionality was in there, anything from shape searching, color searching, edge detections, measurements, and so on. And it became a real sort of, to start with, this is great, we've got so many functions, but gradually then it built into, you're developing systems that a lot of people are very complex and high cost. So it's almost going back to the beginning of the game, but with new technologies that say, well, we can go back to that simple concept that maybe we started off with 20, 30 years ago. But now with the technologies we have, that simple concept suddenly becomes a lot more capable, a lot more, intuitive, easier to adopt, less skills levels and everything. So we're kind of going back to and sort of developing and designing that simple kind of approach to machine vision with the new technologies that we've got in software and in hardware.
Mm-hmm. Very interesting, and I guess I'm really interested in that machine builder aspect, actually, in terms of traditionally, as you suggested earlier on, vision has often been viewed by machine builders as an extra cost, rather than unless the customer is adamant that they want it on the machine. But I guess maybe this opens up the door to more proactive value add onto machines through inspection. Is that a fair comment?
Yeah, I think going back to that word simplicity, the machine builder, they see the simplicity that's available now, and it makes it more feasible as a standard solution on their machines. This is not, do you want it as an extra, an add-on? This is a standard solution. The simplicity levels bring it down, the cost levels, so they position it more as a value creator excuse me, to the customer. Not just an additional investment. They've got to, there's always going to be a cost attached to it, but it's making it the value to that, and getting that over. And coming back again, and a big part of it now increasingly is what we term AI, and the functionality and the ability that a lot of the legwork now in setting up certain inspections really doesn't have to be done by a skilled engineer anymore. In fact, there's software now that pretty much does it for you. And of course, then from an end user's perspective, they start to see we don't need those skill levels anymore. We can adopt this type of system with lower skills, easier integration. There's lower initial costs. The adaptability and the upgradability is there potentially still as well. So if you want to grow it and take it further in the future, you're still going to have that option, or you keep it at a lower level. So there's certainly from both sides, there's real interest now in pursuing and looking further into these technologies.
Now, superb. And you mentioned cost there, Neil, and I'm sure that's a burning question for everybody
Always.
in the audience at the moment.
Always.
What does this look like cost-wise?
Considerably less, without talking figures, maybe less than half the cost maybe of an equivalent sort of rule-based conventional system, maybe more, depending on the application, the number of cameras, and really what you're comparing it against in terms of what an equivalent rule-based traditional system would look like compared to what you're doing now. And of course, we talk about AI, the low-cost technologies don't necessarily cover everything. There's always going to be a need for higher-end vision. What we're trying to do is appeal to the vast areas of the market coming now forward where simplicity is key, and the application base is suited to these sort of technologies. We don't need complex systems. We've really got a lot of application bases that are coming through. And since we started developing and bringing these technologies to market, we're starting to see how big that area is, and these applications and requirements that really are very, very interested in this sort of solution.
No, well, sounds good. Simplicity and cost effectiveness. I mean,
keywords.
If I were buying this kit, I'd be pretty happy as well.
Yeah.
Have you got any specific examples of new technologies that are achieving this?
Yeah, I think the first two words I'd use there is smart sensors. We'll really talk about smart sensors now. We're not talking vision systems. I think if we want to look at vision systems, maybe it's been a system where you've got to build them, maybe cameras, lighting, controllers, things like that. You might have a controller-based system with multiple cameras, so that system better describes that kind of concept. We're talking smart sensors. These are all-in-one devices, with inbuilt simple software, potentially AI as well. And we'll see a little bit of that in a minute. And so I think if we just move away from vision system, we talk smart sensors, all-in-one devices. That's your lighting. Most of the time, it's autofocus optics, and everything, all your control size in one unit. And potentially that control side could be external, but essentially, you buy an all-in-one device and you put it on your machine and you set it up. So, in terms of specifying what you need, it's generally one part number rather than multiple part numbers and things. So of course, then you see the simplicity start to come through. You see the cost reduction starting to come through. Really, it's just about understanding what your needs are in terms of application. In terms of what OMRON are offering, we know we have what we call our FHV7 AI, which is our new AI vision sensor. And essentially, that's what it does. It has 3 AI functions in there. You have the option of adding conventional functions if you want to, but a lot of the time we're talking just simple types of applications that suit the AI functionality of that. We've also got what we call now more of a smart reader, and a smart reader will be ID, 1D and 2D coding. We're now looking at inline verification as well, so not just reading your 1D and 2D codes, but verifying them inline, and also OCR as well. Now, an OCR where there's no dictionaries, there's no training new characters, you simply draw a region and train it. Simple. It's almost a clever kind of, have we got the right font? Do we need to train extra characters? Things like that. Is it good quality? Is it slopey, slanted, different sizes? Doesn't matter. Draw a region around it, it'll train itself and read it. So that's the kind of what we're starting to look at, and the new technologies we're bringing to the market.
No, superb. It definitely sounds like things are getting a lot simpler. You mentioned AI there on a number of occasions, Neil.
Yes.
How's that starting to influence things?
Yeah, I think it's just to expand a little bit on the AI side. It's a familiar term. That's why we and others are starting to use it. And in other industries, everywhere we go now, AI this, AI that, and it's not Skynet from Terminator films or anything like that quite, although who knows where it ends up. But from our perspective, it's a familiar term. People understand it, and to some degree, we are building that extra level of intelligence into the software. What we want to do is remove what might be seen as complex step-by-step systems where you've got to build your own sort of programs and logic and things into something that simply guides you through a series of stages, and at the end of it, you come out with a solution. So it's taken a lot of that legwork away. So really, with AI now, we're talking about certain set functions. We're talking about more machine learning, really, not AI. AI is quite a big bubble. So machine learning is a part of that sits within AI. So we're trying to help machines learn, with the vision system, how to improve those processes and what they're looking for, and identify defects and parts and things like that.
Do you have a specific example of that you could explain, Neil?
Yeah, I think going back to what the sort of functions, it's the key thing with AI at the moment is essentially image based. We're not measuring things and stuff like that. We're essentially presenting data and information to the system through images. So everything we do to train the camera system to do what we want it to do is done through imaging. And we categorize the sort of applications into sort of presence and absence. So we're looking for the presence of something. Is it there? Is it not? Product type, and this might be, go back to your cap, your strawberry cap and an orange cap. Is it the right type of product? And that could be shape based, it could be color based, it could be a combination of all sorts of things. Essentially, if you look at something and you can see a difference, this is what we're talking about. So you can see an orange cap is very different. It's the same shape, different color, but another cap might be the same color but different type. So there's a different shape issue maybe, and things like that. The third category is defects. This is a huge area, a huge problem to a lot of production processes in terms of looking for dents and scratches or damage and things like that. And So, and it can be quite complicated to set up with a conventional system, because you've got to do all the work in terms of how do I identify that? How do I tell the system that's what I'm looking for, and start to filter that out and say, that's what the defect looks like. That, particularly if you've got natural variations in your good products as well. So it's really separating the good from the bad.
Mhm.
So if we look at sort of, have we got an application that requires a presence absence check, checking it's the right product, or for defects, then this is where we're talking now at the moment with AI. And also, as I always mentioned, we can expand it into OCR, reading text, reading ID, 1D and 2D codes, and inline verification. So it's extended into that smart reader concept as well as that smart sensor area.
Oh, superb. So I think it'd be great if you could show us, Neil. Have you got, do you have any examples you could show?
Yes, certainly. I wanted to show today, so I'm going to focus on the AI sensor, so that's FHV7. And I think, if you want to, anyone out there thinks they might want to implement or look at these sorts of technologies, then the first thing you've got to ask yourself is really, what's the application? Am I looking at presence, absence of something? Am I looking at a product type or defects? What we try to do with the software here is make that very simple. It's a simple question. If it fits in one of those three categories, you're good to go. A lot of applications we're seeing are increasingly sitting within those. We're not looking at measuring stuff and things like that. We don't want data. We're not looking for pick and place and things with X and Y coordinates. We simply want to know, is something right? Is it where it should be? Is it the right product? Does it have any defects on it? Things like that. There's a huge area of applications really that sit somewhere in those three areas. So I'm going to try and share my screen. So I hit that. Okay. That will come out okay?
Yeah, we can see that, Neil.
You can see that, good, okay. So first thing I'd like to do is this is the software for our FHV7 AI. So you can see it's quite simple. There's not a lot there. Down the left-hand side, it's a 7-step process, essentially. You start at the top and you work your way down. At the blue box at the top, this gives you pointers as to what you need to do. You've got job lists, a couple of tabs at the top for saving your programs, another one with settings in, and then the right-hand side, really, what we're looking at in terms of response times and things like that. Now, at the moment, I'm just running this from a simulator. All our software has simulator options. So if you've got images and stuff already, you can work with those images offline. Of course, the other options, you connect directly to the camera. So the first 4 steps really are if you connect to the camera. So you've got to get start your adjustments. You then need to essentially adjust the image. And that's very simple. There's 2 or 3 things to do. Autofocus, set your lighting. So lighting's all built in. We've got also, essentially, you're looking at a 1.6 megapixel camera. You're talking also focus lenses. There's 5 different options. Really, there's 5 different model numbers and built-in lighting. Down the bottom here, 1 is very bright and 7 is darkest settings. Really, when you've got a live image, you'll set that to suit your requirements. You'll autofocus it, and the advanced settings don't get much more advanced. So actually, I just want to reduce or adjust the lighting. So we've got 4 quadrants essentially, so you could turn them off, have them at either side or top and bottom, or you can play around with it to reduce glares and reflections and stuff like that. So it gives you a little bit of control in terms of where the lighting and directions it's going to come from. If you're connected to a camera, you generally select start off with a good image and register it as a master, and then draw a region around the area of interest. And that could be a square, rectangle, or a circle. Then you get to your pre-learning stage. This is where you start then bringing images in from the camera and start to set them up in terms of identify what we're looking for. As I said, it's all down to images. So really what we've got to do is build 2 folders of okay and not good images. And that's the case across all the AI functions. Sometimes we want to focus a little bit more on good images because we want to get maybe a range of acceptable variations of those good images. We can emphasize a little bit more on that. It might be we need to emphasize a range of different defects and things as well. So the size of those 2 folders can vary. This requires a minimum of 2 of each. So for a very basic application, that might be enough, but certainly on average 10, 20 maybe of each is generally pretty good and will give you a good starting point. The beauty with the functionality in AI, if when you implement it, you need to add a little bit more, you can easily do that, just add some more images, retrain it, and make it a little bit more robust. Just jumping down to the AI learning bit, once we've connected to the camera and got our images, in this case, what I've already done, this is a defect check, is I've set some images into an OK folder, and I've set some images into a not good folder. The only difference here really with the not good folder, you'll see a little pen device. There's a term called annotation. That basically means we're going to indicate directly on those images what we're looking at in terms of defects. And really, when I click on one of those and bring up my pen, you can see that essentially what I've got here is a bottle with a foil cap. Now, I'm looking predominantly for when that cap's laid on. It hasn't been sealed yet, but I need to know if it's got cork, it's got any creases in it. And as you can see here, it's quite an obvious case of a defect within that cap. So I just draw a circle or whatever free-handed around that. So I'm starting to teach the system what it's looking for in terms of a defect. At the same time, to the good images, I'm trying to show it what I'm looking for in terms of good. And you'll see that, we've got a tab sticking out. So we need to sort of make sure the system knows that's okay. It could be sticking out to the left or right. It might be sticking towards the camera. It might not be in view at all. And with something like this, we might be looking at maybe 3 cameras, so we get that 360-degree coverage. So this is the view from one camera. And adding another 2, exactly the same, copy and paste the program, and then you've got that complete coverage. And I keep looking through this one. There's no tab visible. There's no tab visible. There's a tab visible to the left. So I'm trying to sort of train all this data in. This one here is slightly curved up, but that's fine. We're not interested in that. That will get sealed. All we really need to know is there a crease or a fold in it. So these are all trained. There's natural variations, tabs sticking down a little bit there. That's fine. Again, so I've tried to get a range of, and this is slightly on the slope, that's fine again. So it's getting that. You can start to see, if you're trying to do sort of rule-based function, it gets quite complex because you're trying to tell the system all these situations that are okay. If you haven't got a lot of experience, that becomes increasingly difficult to understand. And then really with the defects, it's getting a range of different defects. We've got a little bit here on the edge, so that's a defect. So you can see no 2 defects are exactly the same. So again, that becomes a little bit more complex with rule-based vision, that you've got to try and tell the system that defect isn't always going to be in the same place. It's not always going to look the same. It could be bigger, smaller, different colors, and so on. So we end up with that range of good and bad. The other thing you'll notice with that image is we've just got a front light on it with various reflections. With a conventional rule-based system, that would be a problem as well. We'd probably have to look at backlighting that and trying to get a silhouette. But then that hides certain things. So really, the fact that we can train that reflection into the good and acceptable regions is another benefit. Once we've done that, we simply then hit the start learning button, and then like I do it in this case here, it'll go and retrain those images. It might take a minute or 2 to do that. What it'll come back with is like a little histogram chart that will show us in graphical terms of where all the good ones and bad ones sit, and hopefully there's a bit of a gap between the 2, and everything's set. So from a skill point of view, there was none really. All I've had to do is take those pictures. All I've had to do is understand what I'm trying to look for in terms of the cap being straight, but it can vary a little bit. But really all I'm looking for is those folds and creases in the cap. That's my defect. Everything else is fine. And that's really all I've had to do and understand. And then I just sit here for a minute or so, let the system work that out. And then we end up this histogram. So you can see we've got quite a nice spread on the right where the red areas are. That's all our bad images. The green on the left is our good images. It's set a threshold down the middle. There's a nice gap. So that's a really good place to be. Close that off, do an operation check. And then what I've got a no good, no K folder. I've got loads of other images then, which nothing to do with those trained images. And in theory, then if I run that through, so we see that variation, and all of a sudden we get a bad one pop in. It picks those out, but it lets those curved ones stay in, and that one there is picked out, and that one there. And for sort of 10 of each, that's not a bad result. And like I said, the beauty is if you feel there's a few areas you've missed, add the images in, retrain it.
Oh, that's great, Neil. I mean, from what you've shown there, it does look pretty simple to do. Well, how long does this typically take? So for an application like this, if we were to simulate,
I mean, it really can be sort of minutes onwards. I would say certainly, once the camera's plugged in and you've got an image, 5 to 10 minutes, you're getting the images in, and you can start setting them up. This one, the defect one, might take a little bit longer. You've got the annotation step. When you're looking at presence, absence, and product type, you don't have that step. So it really is just get you're okay, not good images. If you want to focus on more natural variations in good, get a few more of those in. It's within 30 minutes, and you're up and running with something. And whether you need to just develop that a little bit as you develop more images, then you've got that flexibility. Add them in, press the retrain button, and get that improve that robustness. But really, that's all you really got to do.
Fantastic. Thank you for that, Neil. Much appreciated. Final question from me then for you is, if our customers want to look at this in more detail, or have applications that they feel that they might that this technology might benefit them with, how do they go about doing it?
Right. Okay. Yes, that's a good question. We will make that part of it easy as well. So really, we want to produce a step-by-step guide. Really, ask yourself a question first. What is your application? It might be presence, absence, product type, defect inspections. There could be other categories as well. We're not just talking AI, but we've been talking AI today, the simplistic side. We do other areas as well. So, ask that question and then talk to us. We generally start off having a conversation. If you're able to provide with specifications and product samples, then we offer kind of a free of charge valuation service where we can look at those, the specifications and the samples, and look at developing a proof of concept where we can sort of start to put a proposal back to you in terms of what we think a hardware solution would look like. Is it a simple AI solution? What kind of support might be needed? Understanding your needs, looking at addressing those skills issues and stuff, and the integration side. If we need to, we can obviously visit site and look at the process firsthand to make sure we start to build that solution as a final. There's optional support packages available. Ultimately, and again, we can offer a complete solution. If you need control and other elements, PLC control and so forth, then we can offer the wider solution as well.
Fantastic. Now, I really appreciate your time, Neil, and your expert insights. Hopefully, our audience have taken a lot from your knowledge. I'm sure they have. We don't seem to have any additional Q&A, so we will end the webinar there. So thank you everybody for your attendance. Hopefully, you found it valuable, and we look forward to seeing you on the next webinar. Thank you very much.
Thank you, everybody. Thank you. Bye-bye.